Hi everyone, so today we're going to be continuing our study of logarithms, and as I mentioned in my last video, I'm using these videos for both Algebra 2 and Pre-Calc. So for Algebra 2 you were seeing this for the first time, and for Pre-Calc this is a review of what you have learned last year. And all of you, regardless of which class you're in, you're going to see this next year in your future math classes. So you will see it in Pre-Calc, you will see it in Calculus, you will see it in Stats. You'll see it in just about every other math class that you take beyond this point. So they are important, and in the last lesson I told you how to evaluate them. So today we're going to be looking at some properties of logarithms, but before we do that, I want to go over some exponent rules that you guys have learned in the past, whether it be Algebra 1 or Algebra 2. You saw it in both places. So let me review some exponent rules, because they are related to logarithms. Okay, so this is not on your note sheet. This is just extra examples of something you saw in the past. So say you were given two powers, like x to the third times x to the fourth. So the rule that you learned in algebra is, in a case like this, that you would add the exponents together. So 3 plus 4 would be 7. So you would have x raised to the 7th power. That is called the exponent rule for a multiplication. So another thing you learned is if you are dividing and you have powers, so say you had to divide 8x to the 8th divided by x cubed, the rule is to subtract the exponent. So 8 minus 3 would be 5. So that's called the division rule for exponents. And then the other rule that you learned, there were more, but the one we're going to look at today is what if you had something like x to the 4th and then you raise that to the 6th. So you're raising a power to another power. The rule is to multiply those numbers, so 4 times 6 would be 24. So that is called the power property of exponents. So why did I bring this up? Well, in the last lesson I asked you to evaluate some logs, and the idea is that you were trying to take the base of the log and think what exponent you should raise it to get the other number in the problem. So think of logarithms as exponents. And if you do that, then this is kind of easy to understand. So let's look at the three properties at the top of the page. So there is one called the product property. I'm going to abbreviate that. Okay, so what it's saying is if you have a logarithm with a base of b, and then you're going to multiply two numbers together, think of the two numbers being exponents. So if you're multiplying and you have exponents, the rule is to add them. So you are going to expand this into two logs. They will still have a base of b of one number plus another log, still with a base of e, of the second number. So keep in mind it's exponents. So when you multiply exponents, you add them. Okay, so then there is another one called the quotient property. So this is at the top of your page too. So this is saying if you have a logarithm with a base of b and you're going to divide two numbers like c divided by d, think of those two numbers as being exponents. So when you have exponents and you need to divide them, the rule is to subtract. So we are going to expand this into a logarithm with a base of b of c and then subtract it by a log with base b of d. So think of dividing exponents means subtraction. And then there's one more called the power property that we're going to look at today. And this is of logarithms too. So if ever you have a logarithm with a base of b, and then it's a number raised to a power, think of these as exponents. So if you have an exponent with another exponent, you multiply them. So the way you do that is you take the number d, the exponent, and you multiply it to the log. So a power to a power means you multiply. Okay, so these three rules we're going to now use to work out the 10 problems below this. But I wanted to explain them because in the future you will need to understand this in order to do your higher level math. Okay, so let me show you what I mean. So numbers 1 through 5 say to expand the logarithm. So on those, you're going to start off with one logarithm, and you're going to need to break it up into more than one log. So I'm going to do some really easy ones first, and then some more that are a little more complicated. So this is an easy one. So you have a logarithm with a base of 9, and then you're just dividing these numbers p and q. So division means that would be the quotient property of logs. And if you look at your sheet, quotient means you subtract the logs. So you would write this as a logarithm with a base of 9 of p, and then subtraction, and then a log base 9 of q. And that's it. You're just taking a single log, changing it to more than one log, and that is called the quotient property of logs. So that's it for number 1, easy peasy. Number 2, what if you had log base 4 of 3x? Now keep in mind in algebra, if you see 3x, that means 3 times x, so that implies multiplication, which is the product property. So the rule for the product property is to add the two logs. So that would be log base 4 of 3 plus log base 4 of x. So that's been expanded from 1 log into 2. So this is multiplication, so you change it to addition, because when you multiply with exponents, you add them. Okay. And number 3 is also an easy one. It's log base 3 of y to the 4th power. So this is called a power property, because you're raising a power to another power. You multiply. So what you do is you take the 4 and you multiply it to the log. So it would look like that. So 1, 2, and 3 are very easy. They only took 1 step, and that's it. So numbers 4 and 5 will be a little trickier because you're going to have to do more than 1 step in each one. So let me erase this and go on to number 4. Okay, so number 4 is log base 5 of 11m squared n over p to the 4th. Okay, so this is going to require multiple steps because there are multiple numbers in this problem. There's an 11, there's an m, there's an n, and there's a p. So that means there's going to be 4 different logs in our answer. So let's just do this a little bit at a time. Okay, so each of the logs will have a base of 5. That will not change. So I'm going to start off with log base 5 of 11, just the 11 all by itself. That's going to be one of the logs. Now the 11 is multiplied by m squared. So multiplication means that you would add the logs. So you would put a plus sign and then another log with a base of 5, and that will be m squared. Now the m squared is also multiplied by n, so that means you would have another log added to that, and that would be log base 5 of n. And then there's one more log. Because this is a division symbol, like fractions are division, that means that this number is being divided. So if you look at the quotient rule at the top, that's subtraction. So you would have a subtraction symbol, and then another log with a base of 5, and then p to the 4th power. Okay, so that's the first step, is to write it as 4 separate logs. Now you can go just a tad further with a couple of these, and those are the ones that contain exponents. So the m squared here and the p to the 4th down here, we're not done with those. The first one we are, so we're going to keep that one as log base 5 of 11. Okay, so the ones that have exponents, you have to also apply the power rule. So you will take the exponent 2, and after the plus sign, multiply that 2 times the log. And that would be 2 log base 5m. The next one doesn't have an exponent, so you can keep that one the same. It would still be log base 5n. Now after the subtraction sign for the last one, the 4, that exponent, will be multiplied to this log. So put the 4 after the subtraction sign, and then log base 5p. So there you will have your 4 different logs. This is the final answer for number 4, fully expanded. So we had to first apply the product and quotient rule here, and then we also applied the power rule here. So this bottom one is your final answer for number 4. Okay, so number 5, we have one more. So we have a log base 2, and then there's a cube root sign, f squared and g. So I mentioned this in your last video, all of the radicals can be changed to what are called rational exponents, which means exponents that are fractions. So if you are in my Algebra 2 class, we did this just a couple weeks ago, but if you're in pre-calc, you haven't seen this in a while, I did mention it in the last video though. So here's how it would go. There's going to be two different numbers, f and g, so each one will have their own exponent. So I'm going to do that first, is change them both to have an exponent. So for the f, the 2 would be the numerator, and the cube root, the 3, would be the denominator. So that would be the same thing as f raised to the 2/3 power. Now g would be separate from that, and you don't see an exponent for g, so that means it would be a 1. You just don't ever write g to the first power, but it's assumed to be 1. So that would mean 1 would be the numerator, and the cube root 3 would be the denominator. So it would be like that, f cubed and g to the 1/3. F to the 2/3 and g to the 1/3. Okay, so we haven't expanded that yet. All I've taken so far is change the cube root into fractions. Okay, so now I can expand. Now the f and the g are being multiplied together, and that would mean with logs that you would add them together. So we're going to write this as 2 logs with addition between them. So it would be a logarithm with the base of 2 of f to the 2/3 plus a logarithm with the base of 2 of g to the 1/3. So that's applying the product rule of logs. Then we need to do one more step, the power rule. So because they both have exponents, we need to go one step further. So the exponent will be multiplied to the log. So the first one would be 2/3 log base 2 of f. And then the next one, the 1/3 will be multiplied. So it's 1/3 log base 2 of g. So this one right here would be your final answer for number 5, fully expanded. Okay, so all of those that we've done so far are expanding. That means we started with 1 log and we change it into 2 or more logs, depending on the situation. Now the last, 6 through 10, these are all several logs to begin with, and we need to change them into just 1 log. So when it says condense, we're taking 2 or more logs and changing it into just 1 single log. So let's see what I mean. Number 6, we have a logarithm with a base of 6 of z minus a logarithm with a base of 6 of 4. Okay, so this is an easy one. We only have to do one thing here. Notice they both have a log with a base of 6, so that's the same. They should be the same. And there's a subtraction sign between them. So if you look at the rules in reverse, the one with subtraction between the 2 logs is division. So you would write it as a single log with a base of 6, and you would have the number z divided by the number 4. And that would be it, log base 6 of z over 4. So we took 2 logs and changed it into 1, and all we were doing is following the quotient property of logs. Okay, number 7 is also pretty easy. It's just applying one property at a time. So it's log base 7 of 4, and then log base 7 of g. Notice they both have a 7 for a base, so you're allowed to apply the rules. So this time we have 2 logs with addition between them. So when you see addition, that means you will have multiplication with the logs. So think of the product property of logs in reverse. The one with addition was multiplication. So I'm going to write it just as a single log with a base of 7, and it will be 4 times g, 4g. And that will be it for number 7. You're trying to change more than 1 log into a single log. Okay, so 6 and 7, you just had to apply one of the rules. Sometimes you have to apply more than one in the same problem. So the rest of these will be like that. So number 8. We're just going to tackle it a little bit at a time and apply each rule as we can. So it's 2 log base 3x plus 5 log base 3 and y. Okay, so this is one where we're going to have to apply 2 of the rules. So notice that both of them have a number multiplied to the log, like 2 times this log, 5 times this log. So if you look at the power property of logs in reverse, those numbers were actually exponents. So that's what I'm going to do first, is rewrite this as 2 logs but instead of an x, it will be x squared. Like that 2 became that exponent. Same thing over here. The 5 that was multiplied will really be the exponent over here, so it'll be y to the 5th. Okay, so that was applying the power property of logs in reverse. So now we will do one more thing. We want to change this into a single log. Condensing means you want one log at the end. So if you see 2 logs that are being added, look at the power property of logs in reverse, and you'll see that that means it's multiplication. So you're going to write 1 log, still with a base of 3, and you're going to multiply x squared and y to the 5th, and you just do that by showing them side by side. That implies multiplication. So it would be log base 3, x squared, y to the 5th. So that would be your final answer for number 8. We first applied the power property of logs, and then we applied the product property of logs to get this answer. Okay, so number 9. This one contains 3 logs, and our goal is to get it to just down to a single log at the end. Okay, so tackle this just a little bit at a time. So first of all, look for any numbers that are multiplied to the log, like this 3 multiplied by this log and that 7 multiplied by that log. Those would be exponents if you apply the power property of logs in reverse. So let's leave the first one alone for a sec and change that middle one to log base 4 t cubed. So that 3 that was multiplication is now the exponent of the t. And after the subtraction sign, same thing. Write a logarithm with a base of 4, but it will be v to the 7th power. So that 7 became the exponent of v. Okay, we're not finished yet. We've only applied the power rule. We have to do a couple more things. So next we'll see that the first 2 of these are being added together. So that is the product property in reverse. So on this one we would multiply. So I could change that to a single log with a base of 4, but I'll multiply 6 times t cubed. So you can write it like that, 6t cubed. And then another log. We'll just bring that down for now. So all I did there is use the product property of logs, and I changed addition to multiplication. So I have to do one more thing, and that would be to look at the subtraction sign, and this is the quotient property of logs, and that means you divide the numbers. So you're going to write it as a single log, still with a base of 4, but it will be 6t cubed over v to the 7th power. And then this would be your final answer for number 9. So you want to keep going until you have just 1 log left. That's how you condense. So notice we had to use all 3 of the properties on this one. So we first did the power property back here, then we did the product property, and then we did the quotient property. So sometimes you have to use all of them in one problem. All right, so one more. So we have half log base 5 of 3, and then a half log base 5 of h, and then another one, a half log base 5 of k. Okay, so we're gonna have to do this one a little bit at a time. So all of them have a half multiplied to the log. So those numbers become exponents. So they would all be, the exponent would still be log base 5 of 3 to the half power. And in each case, same thing, log base 5, h to the half power. And then log base 5, k to the half power. So all I did so far was take the half that was multiplied earlier and use it as an exponent instead. So that is the power property of logs in reverse. Okay, so this time you'll see that all of the logs have addition between them. There's an addition here and addition here. So addition implies that it is multiplication. So I can write this as a single log with a base of 5 and have all of these multiplied together. So it's 3 to the half power times h to the half power times k to the half power, like all multiplied together. Now keep in mind that anytime you see a fraction for an exponent, that's called a rational exponent. Any rational exponent can be rewritten as a radical, and a half power is the same thing as a square root. So it would be like log base 5, square root of 3, square root of h, and square root of k. Half power means square root. But rather than writing them as 3 separate radicals, you would probably never leave it like that. You would just multiply these numbers together. So when you studied radicals, you learned that you're allowed to multiply numbers that are inside of the same radical. So for your final answer, I'm going to put log base 5, and then under one square root symbol, 3hk. And then that would be it. This would be the final answer for number 10. All right, so that is properties of logs. And as I mentioned, this will come up again in your future math classes. All of you, no matter what you take in the future, you're going to see logs again. Okay, so if you are in my pre-calculus class, this is your last video from me. I really hope that my videos were helpful to you. I tried my best to still teach you in this situation. It wasn't easy. I know it wasn't easy for you either, so I don't want to say it was only hard on me and not on you. I know it was really hard to keep up with 7 classes, including mine, but I hope that at least the videos were that you were able to do the assignments easily with my instruction. So I really hope it went okay for you all, and I'll miss you very much, and I hope to see you next year. I'm not going anywhere. I'll be in the same building, same classroom. I've been there for over 20 years already, so I'm not going anywhere. So come by and say hi if you're not in my class. So bye to the pre-calculus students. I love you all, and I'll see you next time. Okay, so Algebra 2. You might be wondering, well, why are they finished early? They're not. They're seeing this video a week later than you are because we're learning other stuff in pre-calc right now. So this is going to be just a last-minute review for them, whereas for you, it's learning for the first time, so we have more to cover. So hang tight. There's not much more, just a little bit more to teach you before we're done, and I've thoroughly enjoyed teaching you too, and I hope the videos have been helpful for you. And if you take pre-calc next year, I'm very likely to be your teacher, so I can't wait for that too. I hope I get most of you again. So until next time, bye-bye guys.